Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! First thing I want to address, getting a lot of comments from people saying, where's the bomb? Why aren't you showing us the part numbers of these resistors as we're going along? Because I don't want y'all doing any of this yet. I mean, I can't stop you from, going in here and working on your own amps, but I'm not sure where exactly this is going to end up. And if I send you off to get a list of parts when I hadn't even put them in the amp yet, just going by what's in here and like, oh, we're going to change the front end and add an extra capacitor and resistor to this voltage regulator, then you're going to be pissed that it's like, now I got to order 2 parts and pay $7 shipping because she didn't tell me to order this on the front end. So you're just going to have to be patient. I'm still finding things that are problematic. And some of this stuff is more about longevity and reliability than it is about actual performance, or at least that's what I think I'm looking at. Things like these 450 volt power supply caps that, you know what, they'd probably be okay. They'll probably last for several years. But at some point, they're going to be a problem because they're not rated for the voltage that they're seeing all the time. Same thing with some of these caps on the front end that are rated at 450 volts. I know when the amp's powering up, it's going over that, and they need to be upgraded. So we're adding that to our list. Some of these that are rated at 450 volts, I don't think they need to be rated that high, and the size and the expense of the capacitors are directly related to the voltage that they can withstand. And if they're never seeing over 250 volts, they don't need to be 450 or 500 volt caps. You could get away with 350 volt ones, and they'd be more compact, and they would survive just as well. I did find what I consider a pretty big problem, and that's the choke used in the power supply. It's rated at 4 Henrys, which is good. The problem is it's got a sticker right on it that says 180 milliamps. Now, that'll be fine if you're running EL34 tubes in it, but if you're running KT88 tubes that are all biased at 50 milliamps, or you do what some people online are saying to, they sound better when biased at 60 milliamps. It doesn't take a rocket scientist to do the math to figure out that 180 milliamps is not going to supply power to 200 plus milliamps of tubes. And again, it probably works fine in the short term. I don't know what sonically that may have to do, especially with the bass response, especially if the DC resistance or DCR of this choke is a little high. When you get a strong bass note hits, is this going to be able to supply the power? So I think I found a Hammond choke made for a Fender guitar that will fit in this position, bolted in, and still fit under the cover. I've got one on order. It may be here by the time this video gets started. Not sure, but should be here later this week. And so we're going to be replacing that before we move into this voltage regulator section of the amplifier. Now again, like I said in my previous video, this voltage regulator in my amp, the one sitting here on the bench, is the triodes are wired in parallel. They're not wired in series like the schematic that's online. And so I'm writing a new schematic as I reverse engineer this thing so we can all know where everything is, how it's supposed to go, and then look at ways to improve the circuit. And I think there's a simple mod that can be done to this voltage regulator that really should help split the power supply into basically a dual rail going to the driver tubes, which is something I like to see because that's the most sensitive part of the amp. And if you are going to have some kind of crosstalk between the channels through the common power supply, that's where it's going to happen. And like I said, you may not want to do all these mods. You may say, you know what, I'm okay with the resistors that are inside this thing, and I just want to do the mod on the voltage regulator too. Or you may say, hey, I've got a little hum in my amp. I want to try, doing the twisted pair wire on the power supply and the heaters. I mean, there's all kinds of things you could take away from this. Or you can go full Monty and just do everything that I'm going to do to this amp for this friend of mine to try to take this thing as far as I can without spending an absolute fortune on it and replacing everything. So let's jump into the build. Well, as much as I would like to say we are done with the power supply, we still have a few other issues to address. One of them was some questions people had. How do I wire this transformer up if I live in a country that uses 240 volts? Well, it's very similar to how this is done. You hook the two power leads from the IEC connector and the power switch to these two inside terminals. But instead of bridging this one to this one, and then this one to this one, like you would do on 120 volts, you connect the power here and here. Then you put a jumper. You don't put these two bridges in, and you put a jumper from here to there. But I'll be honest here, and this might offend some people, but I got to be honest here. This switch and the way it's wired up, like, this isn't electronics. This is basic electricity. And again, this might offend some people, but if you can't figure out how to replace this switch, direct wiring up the transformers with these wires all being different colors and going to the transformer, you probably shouldn't be rewiring the inside of an amplifier. Because the problem's going to be, if you don't understand how a double pole, double throw switch works and where the wires would need to go to replace this switch, direct wiring it, if you wire up something wrong in this amp and it doesn't work when you're done, you're never going to be able to figure out what you did wrong. And you really need to do some reading and some research on just basic electricity before you pick up the soldering iron and start replacing a bunch of wiring. So I'm going to also zoom in here to answer a question someone had about the power connector and which wires to connect where. And again, this is a little concerning to me that somebody who is going to be removing and replacing wiring inside of a device like this has to have this explained to them in this much detail. But this is the fuse terminal. This wire here goes to the switch. That's how you know that you have the fuse terminal going to the switch, is that the wire going to the switch is hooked to the fuse terminal. This is the non-fused power terminal, and it's going over to the power transformer. That's how you know that the non-fused terminal is going to the power transformer and not the switch. So, wanted to answer those questions, but again, I'm concerned that someone that is thinking about doing this intensive or rewiring job inside this amp would need that explained to them. And it's probably a sign that before you pick up the soldering iron, you need to get some books on basic electricity and understand what you're doing before you start removing wiring and replacing stuff that you don't understand at all how it works. Okay, so now we're going to jump into the next issue that I found. And this is really starting to get more in depth than I anticipated as far as fixing problems that I'm finding with this amp. And again, this seems like a really well-built amplifier, but there's definitely some issues. Okay, if we look at this choke here that they put in this amp, and you read the sticker that they put on the top of it, which I'm glad they put this sticker on it so I would know this. It's a 4 Henry choke. The problem is it's rated at 180 milliamps. Now again, this isn't rocket science math, but each one of the KT88 tubes is pulling 50 milliamps of current when you have the bias set in the center of the meter. 4 times 50 is 200 milliamps. That's already 20 milliamps over what this choke's rated at before we consider the current that these 5 tubes on the front end are going to be drawing. And so I don't feel comfortable leaving this choke inside this amplifier. Now, having said that, if you're planning on using EL34 tubes or 68.7s or KT77s, the lower current drawing tubes, you're going to be fine. And this isn't a concern. But if you're going to be running KT88 tubes, this guy needs to be replaced. Now, luckily, I got on Hammond's website and was researching their chokes, and none of their just standard replacement chokes, generic ones, would fit inside this amplifier and would fix this problem. But then I went and looked at their selection of replacement chokes for guitar amplifiers, and there's a Marshall guitar amp replacement choke, a 194G. It's a 3 Henry 250 milliamp choke that is the exact same size and has the same bolt down pattern as this choke does. So it's a direct replacement. So luckily we found something that'll work, and I'm not concerned at all going from 3 Henrys to 4 Henrys. It's going to be just a tiny bit less filtering, but with these really big filter caps this amp has in it, and we're talking about the initial B plus that's going onto the plate of the output tubes, that doesn't bother me at all. So this guy needs to go, and then in its place we've got this choke. As you can see, 3 Henrys, 250 milliamps. It bolts right on the little studs that are in the thing. I did have to very slightly file out the outer edge to widen this slot just a breath. And you could do that either with a round file, or you could do it with a drill bit, kind of sawing back and forth to elongate the slots, or just drill the hole out a little bigger if you wanted. But note that it doesn't a perfect bolt in, but it only needed a couple of millimeters at the most on each side to have it bolt in. So we're going to unsolder this choke and solder this one in its place. So let's get busy doing that. First, we're going to unsolder the choke that's currently in here. So the first thing we need to do is unsolder this lead here from this capacitor. And you can see these two are kind of stuck together, so you're going to have to pull them apart like that. I'm going to bend this lead up like this on the new choke. Run the wire underneath those two heater wires. Bring this over, and then first I'm going to tack this lead onto this terminal of the capacitor. And then next I'm going to trim off about that much of this exposed lead. Then come in and wrap this around the terminal. Like that. And then come in and solder that joint together. Just like that. So now we have this choke lead going to this first cap over the choke. Then we need to run the other choke wire to this terminal on the second cap. And so I think it's going to be easier to just cut this wire off than trying to desolder this and end up having this just fall apart on us. And they're probably kind of all twisted together before they're soldered on there. So I think it's going to be a lot easier to just find the wire that goes to this choke and cut it off. Like that. And then have enough stripped off, kind of bend it like that so you can pull it up through here, bend it over, and wrap it around that bundle of wires. And come in here and solder that all together. Just like that. And so now we have a choke installed that is going to be capable of handling the power that these output tubes need to operate correctly. So the last thing we're going to do here is replace this little resistor here that goes to the negative bias circuit. And I assumed because it was a green resistor that it might be a wire wound one. And so I went ahead and bought a wire wound resistor. And it's another nice Vichy little port. And it's like a lot smaller than this, but it's rated at 2 watts, which should be more than enough for the current that this part of the circuit is going to use. So let's go in here and replace this. And then I promise we are done with the power supply. And when you're soldering stuff like this, make sure that you keep the body of the soldering iron away from these capacitors because heat will definitely destroy them. So you want to make sure you don't go like this and lay the body of the iron up against the top of this capacitor and kill it before you even get done with the project. And actually, that was acting so hard to come out, I'm just going to clip it off and solder the new one across there. I don't want to be jerking on this too much and have this whole thing just come apart. They may have twisted that lead together with this diode, and I don't want to have to take all that apart. And then we're going to come in here and that lead in, and then put this other side in. Okay, so we got the power supply all finished. We got 2 new 550 volt caps. We got these upgraded with some nicer caps, replaced all these resistors, rewired the power with twisted pairs of wires. We moved the bridge rectifier up here, twisted these wires, and freed up this spot here to potentially use as a star ground point for future rewiring and replace this choke. Obviously, I hope you don't have to do this. And you don't have to move this bridge rectifier. If you're not planning on rewiring the whole ground circuit and you're just wanting to replace some components, just replace these resistors and these caps. And if you're going to be running KT88 tubes, you need to change this choke. If you're going to be running EL34 tubes, you don't. And then these 2 caps need to be replaced with 550 volt versions. Now, going into the next stage, I'm going to be looking at the input tube and the phase splitter, how they're wired up, how they compare to the schematic. I'm already seeing that there's some parts missing in this amp that are in that schematic. The other thing we want to be careful of is because this amp has so much direct coupling on the front end, which means there's no capacitors between the sections to block the DC, you have to be real careful about ensuring that the voltages remain right so that when you get the one stage feeding the next stage into its grid, that you have the relationship between that next stage's grid and the cathode correct, so that the tube's biased right, because that's what biases the tube, is the voltage off the previous tube's plate going into the grid of the next tube versus where the cathode's sitting. And you need to maintain that little bit of negative voltage compared to the cathode on the grid to make sure the tube doesn't go nuclear. And so, you can't just go in here and start jumping resistors or, changing resistor values and saying, I'm going to jack the plate voltage up on this tube. It could throw the whole direct coupled front end of this amp out of whack. So we're going to be looking at those relationships. Again, I'm putting together a schematic with the voltages, with all the resistor values, how this thing is actually wired versus what I've seen floating around on the internet. And I want to have a readable version where you can read all the values. Now, I'm not going to go into the schematics of the remote control and this switching stuff and these relay boards and all that stuff. Until I have a problem with that stuff, I'm not really interested in trying to reverse engineer these circuit boards or even really pull them out of the amp. And so we're not going to be doing that. So we're going to be focusing on the parts that make the sound good. I am a little disturbed by the way the headphone jack is implemented. And honestly, I'm not a real fan of headphone jacks on tube amps, especially a 45 watt tube amp. If you want to listen with headphones from a tube amp, go get a headphone amp. They're not a whole lot of money, or build one. I really feel like that the way this headphone jack is implemented, we've got the negative side of the speaker outputs running around from the back of the amp up to the headphone jack through some little micro contacts inside this headphone jack, and then back over and then hooked to the chassis ground, which all that seems crazy. I would much rather have the negative side of the output transformer going directly to the speaker terminal and then ground that speaker terminal to the chassis for safety reasons in case the output transformer shorts out. And so I need to talk to the guy who owns this amp and see how, if he really wants this headphone jack. If this was my amp, I'd be yanking that headphone jack out and wiring the output transformers directly to the speaker terminals. So that's something else we'll be looking at in the future. And there's the Dolly cameo. So anyway, hope you're enjoying this content. Hope you're enjoying the channel. I'm loving working on this R8. While I am finding some problems with it, especially if you're someone who is not real good at doing like the fabrication work, or that kind of shied away from building something because the fabrication work seems daunting. This is a great way to get into DIY tube stuff without spending a fortune. And I mean, maybe for some people, a $1,000, $1,200, $1,400 amp, whatever these things are selling for, wherever you get them, seems like a lot of money. But in the scheme of things in the audio world, that's pretty cheap. And if you look for a really high quality KT88 push-pull amp that puts out the power this thing does, that is all ready to go with great parts in it and everything, jam up, you're going to spend $3,000 or $4,000. It's a way to get into this on a lower price point and then do these mods to it as you have the money to invest in it. Like, you don't have to go out and buy new tubes right now. And honestly, now's probably a bad time to be buying tubes. So maybe live with what's in here or play with the front end tubes and just enjoy the KT88 tubes this thing comes with just as it is, and work on doing some of these inexpensive mods, placing these resistors and electrolytic caps. Man, we're talking peanuts, really. I mean, it's less than $100 for the whole big order of everything. And even the coupling caps, going with some good ones, you're spending less than $100. So in the scheme of things, These mods are less than what somebody would throw at some fancy interconnect cables or a power conditioner or some other thing trying to get better sound out of their system. So anyway, hope you're enjoying this fun content on this R8. We're going to keep rolling on this thing. Expect probably 1 or 2 videos a week. And I know some of y'all are, ready to see this thing get wrapped up. That's not how I do things. I work slow and methodically through the amp. You're not going to see a bomb until I'm completely done with this amp and I'm happy with the results. You're also not going to see the schematic. And when I'm ready, all that stuff's going to be on my website. So anyway, if you're enjoying the content, please subscribe, hit the bell, like the video, and we'll be back for some more R8 fun soon. Have a great day.